So I've recently been looking at my channel, and for those 184 subscribers that subscribe to my channel for whatever reason, I decided that I'll make a new video about a computer game I've been playing recently. It's called Shenzhen IO, and it's basically about programming microcontrollers. So I know it's a bit weird, and this channel for the past 1 year has been more about gaming, but well, whatever. Let's just join these two things together, since programming has always been a bit of my forte. So, without further ado, today I wanted to show you the recent design I've been making in Shenzhen IO. This is about a Lazer Tag product, and it took me several hours to complete, but this is the final design. So I'll be trying to describe it, what it does, and basically getting it working again, step by step. So let's just call this design YouTube, because it's going to be for YouTube. Alright, so firstly, let's discuss what we need to actually be doing here. So we have some information here. So what we're creating is a Lazer Tag equipment, I guess, chip or whatever. We have several inputs and outputs here, and some of them will need to give us some state that we will then process and give some output based on those inputs there. So a hit is a simple input connected to an array of laser sensors on a vest. So I guess a Lazer Tag vest. We have also a respawn and an alive output here. Interesting. We also have trigger and reload. So here, so I guess trigger is what we have on our gun, and reload, we can reload our pistol, Lazer Tag pistol. We also have fire, which is a simple output. They're saying connected to a laser pistol. Alright, so firstly, when our player is hit, the vest should be set to not alive. Okay, so basically I think that the alive state is what we need to manage here. And if the player is hit, they are basically dead, so the alive signal should be set to 0. When the player is respawned, their vest should be set to alive. So again, if we get information from respawn, then we should turn on the alive signal. When a player reloads their gun, whether alive or not, their ammo count should be set to the ammo reload value. So I guess this piece of information here is the ammo count. If a player reloads, then of course they should get the ammo that is here. So yeah, and they can reload whenever they like, so they can be alive or not, doesn't matter. If they reload, their gun gets reset. Alright, when the player is alive and pulls the trigger and has ammo remaining, the gun should fire and the ammo count should be decremented by 1. Yeah, seems quite simply very logical, right? You have to be alive to shoot, you have to have ammo, and you have to pull the trigger. So I guess this is going to be the toughest thing to control here, to manage here. There are a lot of if statements here, and to allow for realistic operation, blah blah blah, the ammo reload value is set by the operator and can be read as an XBus input. Okay, so this is basically saying that we have our ammo count here, so this can be changed, but this is static information for now. Anyways, let's use the MC6000 controller, because I can already see the two states that we're going to have to maintain here. So we have the alive state and we have the fire state, right? If we go to the verification tab, we can see that hit, respawn, trigger, and reload are our inputs, and our outputs, or rather the other way around, the inputs into our system are these four, and the things that we need to output are the alive and fire signals. So that's what we're going to try to do. So to keep our state, whether the player is alive and I guess, the current ammo count. So we'll store them in the accumulator and the data storage here, respectively, in this microcontroller. So what was also recommended to me here was to use the DX300 controller, or whatever you call these things. I actually read the PDF about it, and I received some information that it basically takes all of those inputs that are quite complex, and it tries to turn them into a simple output signal. So this is going to simplify things a lot for us. Especially, it's going to make us not have to use so many microcontrollers, because we can just output one X-bus signal here. Same goes for this part right here. So we have the hit, we have the respawn. Let's just move this the other way around. Maybe just move it a bit here, so we have some more space. So we're going to connect it here. Maybe let's move it here, and of course connect it to our output here. Okay, so we have the information going in through here and here, and we also have to have our outputs. So that's what we're going to do. Let's just move this a bit back here. So we'll just say whether we're alive. So this is a P0 compatible pin, so that's how we'll connect it. Same goes for the fire thing here. So our controller will have to output the signal here. But I see that we have this data tunnel here, so we'll just make it a bit shorter and connect it via a bridge. Okay, so we should be all connected now. Thing is, we'll have to decide what we put into this controller here. So this is going to be our biggest challenge for this schema here. So firstly, let's just see what happens with the various inputs. I can already see that we're going to have a bit of a problem getting all those 14 lines of code that we can do here. We can write, this is a limited space, so I think we'll be trying to use a different microcontroller. And the way I did it is basically I used two controllers. I used the MC4000 here to basically manage our hit and respawn states, so simplify them. So yeah, let's try to connect this via the X-bus to our data here. So now this is going to be working in a very simple fashion. Basically, the signal that we're getting is either the hit or the respawn, and based on that we want to set the state in the data here to always be sent no matter what to our alive pin. So either it's going to be sending 0 or 1. As we can look at the verification tab, we have the alive signal here. So we should be outputting either 0 or 100, right? So this is how it's going to work. This little state here is going to work out the value for us, then transmit it over the X-bus to this microcontroller, the main one, which is connected to everything. And at the end of this cycle, it's going to take the value from this controller here and pass it on to the alive pin. That would be the ideal situation anyway. So let's just try to see what we can do here. Firstly, I'll try to see what kind of signals I'm getting from those pins and what does this little thing do with them. So to do that, I'll just move the value that I'm getting. Now, what pin is that? That's the X0 pin I can see here. So we'll move the X0 pin to our accumulator over here and sleep for 1 time duration. Let's see. So by step, I'm going to be testing for hit and respawn. So firstly, let's see what value we're getting on the respawn hit here. So let's do this. We're still getting nothing. Okay, now we're getting 100. Let's see what the readout value is going to be. Okay, it's 100. Great. So let's take our note here and just add that respawn is going to be 100. Now let's check this for the hit value. So this is going to be here. So let's just wait for it. bit. Okay, great. So this is a 1 we can see. So if we're getting 100 here, this little thing transforms it into a 1. So that's great news for us. So let's just type it here. Ahead is going to be 1. Right, so we need to be sending either a signal which is 0 or 100, as we can see here. We have the expected tab. So if we get hit, we should be transmitting not 1, but 0. So this is basically what this controller will try to do. So yeah, let's do it that way. So firstly, if we get the respawn signal, that's going to be 100. So if x0 is 100, let's just move 100 to ACC, to accumulator. However, if x0 is 1, then we want to move 0 to our accumulator. And then we want to sleep for 1 sequence. Right, so why are we moving this to accumulator instead of sending it straight away? Well, this is pretty simple, because we want to always be remembering the state that was like existing previously. So the reason here that we are using the accumulator is that, for example, if we are alive and we get a respawn, then we always want to be sending the accumulator value. So we'll of course set the accumulator to 100, sorry, if we get a respawn signal here, but we want to keep sending it because that's the alive pin here. And if we don't use the accumulator, if we don't store it somewhere, then we'll just be sending a live signal just like we have here. It's going to be just for 1 time duration, and then it's going to drop to 0 again. So that's unacceptable for us. And of course, I forgot. At the end of the cycle here, just before we sleep, we need to actually be sending our accumulator to the X1 pin and handle it here. So let's do a test. Let's read the X1 pin and move it to the accumulator. So let's see if it works. Alright, so here we have the respawn signal. Let's see what happens in our accumulator. Let's advance a bit. Okay, we're getting a respawn signal. Now it is being stored in our accumulator. And we can see that the microcontroller is waiting for the input here. So it's waiting for this thing to send the signal over. Okay, the accumulator is 100. We're moving the accumulator into this pin. Great, so it is 100. So then I suppose that the alive pin would be sending this signal right here. So we need to actually code that, because right now it's not sending anything. So let's do that. We're going to move this signal, X1, we're going to move it into the data, and then let's move the data to P0 and sleep for 1. Okay, that's perfect. We can see that the alive signal is being dealt with correctly, right? So here the player got hit, and immediately we reset the alive signal to be 0 as expected. So that's great. Now we should handle the trigger and readout logic. So let me just remove this part here. Okay, so at the end of our cycle we're always going to sleep anyway, so let's just leave this here. We also want to keep that alive information in our data for now, because we will of course need to be checking if a player is alive when the trigger is being pulled. So if the player is dead, we'll not fire off a signal here to this P1 pin, because if a player is dead they cannot shoot, obviously. So let's try to do this. Firstly, we need to hook up our ammo count here just to get that information into our system. And now what we need to do is we need to check what kind of information we're getting from this side. So yeah, if we get a trigger, what kind of signal will we receive in the X3 pin? So that's what we're going to be doing. Let's move the X3 into the accumulator and we'll see what happens. Alright, so we have the trigger here. The signal is being sent. Let's see what kind of information we're going to have in our accumulator. Okay, so that's 100. So if the trigger is being pressed, we're getting an information of 100. So let's store that in a note here. Great. Let's check this for the reload. We have a reload here, so let's advance to that point. Okay, the reload signal is active. Let's see what kind of information we'll get into our accumulator. Okay, that's a value of 10. We can see here. So let's store that information in our node here. Great. So now we can actually react in some way to these signals, I guess. So the first thing we want to do is we want to check if the player reloads, because if we analyze the verification tab here, we'll be able to see that the trigger is being pressed almost immediately. However, no fire output is actually being generated. So why is that? Well, that's very simple. Because the reload hasn't been triggered yet, the actual ammo count in the player's pistol is 0, so obviously they can't shoot. So what we need to do is we need to check, the first thing we check is need to be for the reload. So the reload is 10, so we'll just check whether X3 is emitting the 10, the signal which equals 10. So if it is, we want to actually reload the gun. So how do we do that? Well, I'd like to store the information about the ammo capacity or ammo situation in the accumulator, because we can perform very easy arithmetic informations on it. We cannot do that with the data information, with the data storage here. So that's vital that we use the accumulator for this. So let me just create a very simple note here. I'll be storing the alive and dead signal in the data. So when the player is alive, I want the data to contain 100. And if the player is dead, I want the data to be 0. Those are the signals we're going to be sending directly to this P0 pin. And the ammo is just going to be kept in the ACC. Great. So now, if the player reloads their gun, obviously we need to move the ammo count into the accumulator, because this is the maximum ammunition that the player can have. So let's move the X0 pin into the accumulator. Alright, the next thing we're going to be checking is, of course, if the player is actually pulling the trigger. So we'll need to check for the value of 100. So let's do that. We're checking if X3 is equal to 100. Great. So now we have a few things we need to be checking. We need to check if the player is alive, and if the trigger is pulled, and has the ammo capacity, has some ammo remaining. So of course the ammo count cannot be 0. So yeah, we're checking for the trigger already. Let's chain that together with the ammo count check. So TGT ACC 0. So TGT is checking basically if a value A, in our case the accumulator, is greater than 0. So obviously if we're storing ammo in the accumulator, we are checking here if it's greater than 0. So that works. Next thing we need to check, of course, we need to see if the player is alive. So we have our information here. The player is alive if the data stores a value of 100. So let's just check if data has 100. Okay, so if all of these values are correct, we actually want to fire off a shot. So let's move the signal 100 to our P1 pin. Great. So that's not the only thing we need to be doing though. We need to, of course, decrement the ammo count by 1. So firing costs ammunition. So let's just perform this easy sub function on our accumulator. So we're going to remove 1. Great. So I guess that the logic for shooting is completed. However, what we need to remember is that firing takes 1 time unit. So after that, we need to reset the signal to be 0 again. A player cannot be firing all the time when they just press this trigger once. So after that, if the player is actually not shooting, we need to be sending a value of 0 to P1. Okay, great. So now, the last thing we need to be doing is, I believe, we need to be sending our alive signal constantly. So that's the last thing that we're going to be doing. I'll just move it down here. So we need to move the data signal to our P0 pin. So now, all of this should be working. Let's run the test. Great. It seems that everything is working. We can see the accumulator being decremented and the state being changed here. So all the tests and the outputs are just as we expected. So these are pretty average scores. I mean, I have a bigger power usage than the average lines of code and average price. So this isn't some perfect little mechanism. I'm sure that it can be streamlined, especially with using like some data storage techniques from here or some logic pins, but I don't know how to use them yet, so I'm just using whatever I know how it works basically. So if you see an improvement that I could make for this design, please write it in the comments. And I think I'll be making some more tutorials for Shenzhen IO. It's been a pretty fun little game. So yeah, stay tuned for more and see you next time.